This is CPM Calculus, Chapter 6, number 74. From her second floor window, 6 meters above the ground, Xiaomara throws a tennis ball at the rate of 11 meters per second up towards her friend Itsaguri, who is 12 meters above the ground. Assume the acceleration as a function of time is negative 9.8 meters per second squared due to gravity. Okay, that's what we're given. Part A says, assuming Itsaguri does not catch the ball, describe the motion of the ball 2 seconds after it was thrown. So we know acceleration is negative 9.8 meters per second squared. We know the ball goes up, right, just like we have in green here, and then eventually goes down. Velocity, we know, is the integral of acceleration. Plugging in negative 9.8, we get negative 9.8 t plus c, right, plus the constant, because it's an indefinite integral. But we know that the initial velocity at time is 0, the velocity is 11. So if we plug in t is equal to 0, we can solve for c, because we're given in the problem that the ball is thrown up at a rate of 11 meters per second. So c is 11, then we get the equation for velocity being negative 9.8 t plus 11. All right, so finally we say, well, at 2 seconds, where the question is asking, what is the motion of the ball? Well, the velocity at 2 seconds, you plug in 2 into the equation, you get negative 9.8 meters per second. Therefore, after 2 seconds, the ball is traveling downwards, right, at 8.6 meters per second. The negative there tells us the direction is down. All right, let's go into part B. Part B says, when does the ball reach its highest point? So highest tells us maximum height means the derivative of the height function equals to 0. We know that that gives us critical points where we have maximums and minimums in our height graph. So our derivative of height is going to be velocity. So we're going to see where our velocity is equal to 0, or negative 9.8 t plus 11. Solving that for 0, we get 1.122 seconds. Okay, so then we know that the maximum height is at a time equal to 1.122 seconds. Part C is, will the ball reach Itsaguri? Okay, so remember, she's 12 meters above the ground, and Xiaomara throws the ball from 6 meters above the ground. So, well, we can find the equation for height by doing the integral velocity. So if we do the integral, we get the velocity is equal to negative 9.8 t squared divided by 2 plus 11t plus c. But we know the initial height when she throws that ball is 6 meters above the ground. So we can say at t is equal to 0, the height should equal to 6, and we can solve for c. So c is 6, we get the height equation. Okay? We know the maximum height was at a time of 1.122 seconds, so we plug that in. At time is equal to 1.122 seconds, we plug that in, we get a height of 12.173 meters. So the ball reaches that high. So yes, the ball will go up past 12 meters where Itsaguri is, so she will be able to, she'll be able to catch it if she wanted, right? Because it can go that high. All right, part D. Part D says, determine how high the ball is when it is falling at a rate of 5 meters per second. So assuming she doesn't catch the ball, so it goes up in the air and then goes down, we're looking for velocities equal to negative 5 meters per second. So we need to pay attention to the wording of the problem, because falling means the speed is negative, right? Or the velocity is negative because the speed is going down, okay? So plugging this into our equation, we know the velocity is negative 9.8 t plus 11. So we set it equal to negative 5, and we solve for t. We get t is 1.633 seconds. At t is 1.633 seconds. What is the height of the ball? We plug into the height equation we got in part C. Yep. And we get the height is 10.898 meters. So when the ball is going down 5 meters per second, we know that the height of the ball is 10.898 meters. Finally, we're asked to describe what is the integral from 0 to 2 of the acceleration. What does that represent physically? We know that this, the idea is the area under the acceleration curve from 0 to 2. But physically, if we look at it in the real world, that's basically the change in velocity in the first 2 seconds, right? The acceleration, we're going to take the integral of acceleration, giving us velocity, and starting at time 2, subtracting from time 0. So we're getting the change in velocity in the first 2 seconds. And this is going to introduce us to topics we're going to see in the future. And that's going to end for us CPM Calculus Chapter 6, number 74.